Hello everyone. So in the last video we had talked about Euclid's division lemma, and now in this video we are going to take it forward and we'll talk about more applications of Euclid's division lemma whose steps make the Euclid's division algorithm. Now, do you know what the word algorithm means? Algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. And the word algorithm comes from the name of the 9th century Persian mathematician Al-Khwarizmi. And we can say Euclid's division algorithm is a technique to compute or find out highest common factor HCF of two given positive integers by applying Euclid's division lemma several times. So let's take an example. Let's find the HCF of 455 and 42. So we can write down 455 is equal to 42 is the divisor, and we multiply by 10. Quotient is 10 and remainder is 35. Now the previous divisor becomes dividend and remainder becomes the divisor. So 35 into 1 plus 7. Now again the previous divisor becomes the dividend and the remainder becomes the divisor into 5 plus 0. So this is what we have been doing when we find the HCF by long division method. So I made a video on how to find HCF by long division method. I'll adding the link in the description box so you can watch that. So now here the remainder has become 0 and we can't proceed further. Therefore HCF is the last divisor 7. This is also known as the successive division method. So now we can say that we can follow few steps to obtain the HCF of two positive integers. So let's take two numbers A and B where A is greater than B. So for the first step, we can apply Euclid's division lemma to A and B. We get whole numbers QR such that A is equal to BQ plus R and R is greater than or equal to 0 and less than B. Now if R is equal to 0, then B is the HCF of A and B. But if R is not equal to 0, then we have to apply the division lemma to B and R now. And now we'll continue this process until we get the remainder as 0. And the last divisor will be our required HCF. Let's do one more example here. So let's find the HCF of 4052 and 12576 using Euclid's algorithm. We know 12576 is greater than 4052. Applying division lemma to these two numbers, we get 12576 is equal to 4052, which is the divisor, 3 times, and we get the remainder as 420. Now again applying the division lemma to 4052 and 420. So 405 and we divide it by 420, and now this can go 9 times and remainder we get as 272. The remainder is not 0. So again we are going to apply division lemma to 420 and 272. So 420 and 272. This would go one time and we get the remainder as 148. Now remainder is not 0. So again we'll apply division lemma to 272 and 148. So 272 here becomes dividend and 148 is the divisor. Again one time and we get the remainder as 124. Still the remainder is not 0. So again we'll apply the division lemma to 148 and 124. So 148 is equal to 124. Again one time and we get the remainder as 24. Remainder not yet 0. So we'll apply division lemma to 124 and divisor is 24 into 5 times now and we'll get the remainder as 4. Still we can continue applying the division lemma. Now 24 becomes dividend is equal to 4 times 6 and we get the remainder 0. So now we cannot move further. So the last divisor is the HCF 4. So therefore HCF of 12576 and 4052 is 4. So in this way we kept on applying Euclid's division lemma until we got the HCF, and this forms an division algorithm. And this division algorithm is not only useful for computing HCF of very large positive integers, but also because it is one of the earliest examples of an algorithm. These days we are using a lot in programming our computers, and this has become a very important concept these days. So for more concepts, stay tuned and see you all.